Okay, now we are going with the numerical problem on the basis of Gay-Lussac's law. The question is, what volume of ethyne? Ethyne means it is alkyne group CnH2n minus 2. Gas at STP is required to produce 8.4 decimeter cube of carbon dioxide at STP. So this question, it has already appeared in 2014. So if they don't give you any equation, then you have to form equation, then you have to balance the equation. Here they have said ethyne. So the formula of ethyne is C2H2. When it reacts with oxygen, it produces, what does it produces? It produces carbon dioxide plus water. Now we have to balance this equation. So if you want to balance this equation, let us balance this. Now you can see this is already balanced equation. Now here they have asked you the relation between ethyne and the relation between carbon dioxide. So using in board you write using Gay-Lussac's law, what we know that two volumes of ethyne produces 4 volumes of carbon dioxide. That means one volume will produce 2 volume of carbon dioxide. But here we have got here 8.4 decimeter cube of carbon dioxide. From this we can write it down that 2 volume of carbon dioxide is produced due to 1 volume of ethyne. Therefore, 1 volume of carbon dioxide will be produced due to 1/2 volume of C2H2. Now here the volume of carbon dioxide is given how much? 8.4 decimeter cube. Therefore, after this you can write that 8.4 decimeter cube of carbon dioxide will be produced by using 8.4 into half, which is equals to 4.2 decimeter cube. In this way you have to find out the answer. So this is your final answer. Thank you. Okay, one more question is written in the book, that is a mixture of 10 centimeter cube of carbon monoxide, 60 centimeter cube of hydrogen and 25 centimeter cube of methane are mixed with 750 centimeter cube of air. Here it is written 750 centimeter cube of air, idea, containing 20% oxygen. Here this is the volume of air in which 20% is oxygen. So then you have to find out calculate the composition of the resultant mixture. We have to calculate the composition. In this question, you have to first, when you read out the question, try to underline this first. This is 750 centimeter cube of air is written here. That means here considering the mixture, air is considering the mixture of nitrogen and oxygen, and here 20% oxygen is there. That means how much volume of oxygen we can get. First we have to find it out. Number 1, volume of oxygen given is equals to, they said 20% of 750. Centimeter to the 150. So 150 centimeter cube of oxygen you have, and if you multiply from 750 minus 150, 750 minus 150, that means 600 centimeter cube of nitrogen, 600 centimeter cube of nitrogen is remained in the mixture at the end. My dear, you have to understand this first. So how much you are getting oxygen? We are getting 150 centimeter cube of oxygen to be ignited to get with the following reaction. So this is the first step you have gone through. 600 centimeter cube of nitrogen will be in the mixture, remaining mixture, and we have to use 150 centimeter cube of oxygen in the given equation. Now let us step 2. 10 centimeter cube of carbon monoxide when it is ignited. This is the first. Now step 2. What is given here? Carbon monoxide, CO plus O2 gives, what we get here is, try to understand this question again. What is given here? Here it is given 10 centimeter cube of carbon monoxide is ignited. So now we have to balance this. So how we can balance? If you write here 2, see here, now it has been balanced. Now using here Gauss, write on here, using Gauss, using Gauss law. What we can understand from here, 2 volumes of carbon monoxide is reacted with 1 volume of oxygen to produce 2 volumes of carbon dioxide. So what is here? A mixture of 10 centimeter cube of carbon monoxide is used. That means 2 volume, this is 1 volume to produce 2 volume of carbon dioxide. Now let us write down here a mixture of 10 centimeter cube of carbon monoxide. So 1 volume will require half volume of oxygen to produce 1 volume of carbon dioxide. So 10 centimeter cube will require 10 centimeter cube will require 10 by 2, that is 5 volume of oxygen will produce 10 volume of carbon dioxide. So this is our second answer. So here we are already 5 volumes of oxygen is being used from this and to produce 10 volume of carbon dioxide. Now let us go with the third step. What is given here? 60 centimeter cube of hydrogen that is ignited with oxygen. So you will find out this now. So let us rub this. And writing this equation, 60 centimeter cube of hydrogen. Let us balance this. Now we can write by using gaseous law, again we can write here 2 volume of hydrogen requires 1 volume of oxygen to produce 2 volume of water. So 2 volume of hydrogen requires 1 volume of oxygen. So here how many volumes given? 60 centimeter cube. That means for 60 centimeter cube requires 30 centimeter cube of oxygen. Okay, it will produce 60 centimeter cube volume, 60 centimeter cube of water. So this is the one more thing. From here all the hydrogen has been used, oxygen out of 150 we have used previously, and rest 30 centimeter cube has been used from 150 to produce water. Next is given 25 cc. This is your third equation. 25 cc of CH4, that is methane. Let us write here equation 3, methane. When it is ignited, we get carbon dioxide plus water. Let us make a equation, stable equation, that is equilibrium. So let me write it here. So let us rub this one. So when methane is ignited with oxygen, we get carbon dioxide and water. So if you balance here, let us balance this. So we are getting CH4 plus 2O2 gives CO2 plus 2H2O. That means one volume of methane gets reacted with 2 volumes of oxygen to produce 1 volume of carbon dioxide plus 2 volume of water. That means what, here 25 centimeter cube of methane has been used. So 25 cc of methane requires 25 to the 50 cc of oxygen to produce 25 cc of carbon dioxide. Now from equation 1, 2 and 3, what does we get? We'll try to understand. Okay. So adding up the 3 equations, what we have done, now we are going to find it out, resultant mixture. Already nitrogen, the air was 750 as we have done it, and the oxygen percentage was 20, then 20% of 750 was 150. If you subtract this, you get 600 centimeter cube of nitrogen. So in the final mixture, we have nitrogen as 600 centimeter cube. Then we go with oxygen. We had 150 of oxygen. We have to ignite this 150 centimeter cube of oxygen, where oxygen has been used in the 3 equation as 5, 30 and 50. Naturally, finally we get 65 centimeter cube of oxygen will be remaining in the resultant mixture, and for the carbon dioxide so produced is 35 centimeter cube. So this is your resultant mixture and resultant answer. Thank you. If you have any problem, you can contact me by raising your fingers in the comment box. But yes, do not forget to subscribe and ask your friends to go through this channel.